So you're probably watching this video if you missed class or if you wanted to refresh on the lesson. And the lesson was about primarily about stratified samples in this activity using random sampling. So the scenario is Taylor Swift's concert promoter wants to find out how much fans enjoy the concerts. He will ask fans from 1 to 100, where 100 is the most, how much did you enjoy the concert? The section he wants to survey is 50 seats, 5 rows by 10 columns. The stage runs along the top edge of the venue where Justin is pictured. He wants to take a sample of 10 seats. So we're going here, and what you can do is you press the SRS button. So I had already done it with the class, and here's the sample I had. So when I went to the packet, I went ahead and highlighted the different X's in the sample. So if you look at my activity, you see the 2 X's there and then 1 there, and you see, boom. So I highlighted these. So the numbers you see here are not the seat numbers, but they're actually the satisfaction. So how satisfied every fan was at this concert. So this person had a 68 satisfaction rating, but the person up front here had a 90 satisfaction rating. So we let the Desmos take the sample, right? So it already did, and there it is. So if you go to the Desmos and press the SRS button, it's going to give you your own sample. The next thing you want to do, well, first of all, I wanted to look at the sample and look what a simple random sample looks like. One of the questions is it possible to have 3 fans in a single row? And you can see right here on the top row, right here, yeah, it's there are 4 fans on the top row. In fact, let's look at that. I've got 4 fans up there. Is it possible to have 3 fans in a column? Oh, yeah, look. Now, the reason that it's possible to have 3 fans in a row or 3 fans in a column is because this is a simple random sample, all right? How do we take simple random samples? Well, I'm going to go ahead and skip down here to the directions. You would number the seats from 1 to 50. You would generate 10 unique random numbers from 1 to 50. So you're not going to have repeats. And then you would average the results for those seats. So in my sample, the random numbers it generated was seat 2. In fact, let me go ahead and put that up there. So this is seat 2, right? And then we have looks like seat 6 over here. And then you had seat 9 and 10. So that's the beginning of my sample. And then you can see I got seat 12 here and then seat 18 there. So the way it did it is it just basically generated 10 unique numbers from 1 to 50. So that's why I have 10 different seats highlighted. And we don't care about rows and we don't care about columns. We're just picking from the random numbers like we did with the rectangle activity. So is it possible to not have fans selected in the front row? It is possible, but it's probably not very likely, but it is totally possible. Is it possible not to have fans in the last column? Sure it is. And actually you can see in column 1, column 3, and column 5, I have no fans selected. Why? Because we don't care about columns. We're not treating those as special groups. And we don't care about rows. We're not treating them as special groups. So then we went ahead and we wrote down the average enjoyment for our sample. So I have some class data I'll show you here in a little bit. And my average for this sample is 81.9, okay? And then again, there are the directions on how to take the sample. Number all the seats, 1 to 50, 10 unique random numbers, and average results for those seats. Then we went to stratified by row. So I let the Desmos, so we go to the Desmos next, right? And here is where you calculated, and you can see there's my calculation. And then I said, okay, stratify by rows. So what does that mean? Well, what we're doing is we're getting 10 total, right? But I need to get some from each row. It should be equal. It's not always equal, but it should be equal. That's the traditional way to do it. So if I have 5 rows to choose from and I want to get 10, I'm going to get 2 from each row. So you can see here's 2, 2, 2, 2, 2. So if Is it possible to have 3 fans in a single row? No, because we're purposely getting 2 from each row. Is it possible to have 3 fans in a column? It is. I didn't see it in this particular sample, but it could totally happen. You can see I have some columns with no fans picked. So let's see. Oh yeah, because I have 10 columns. And so I have some columns with 2, some columns with 1, and some columns with 0. Is it possible to not have fans selected in the front row? No, we need 2 per row. Is it not possible to not have fans selected in the last column? And you can see I have no fans selected in the last column. So because I don't care about columns. Why do I not care about columns? It's because we're stratifying by rows. We care about rows. Rows are our strata. Okay. So we get down here, and how would you do this? So I'm going to show you that I can tell you what my random number generator probably was doing. So on the first sample, it did 2 and 8 for row 1. All right. Then it picked person number 5 and 7, and that was from row 2. Right. Then it picked person 3 and 4 from row 3. Then it picked person 3 and 9 from row 4. And then finally, last but not least, person 1 and person 8 in row 5. So it took 5 different samples. All right. So this is where my sample came from. Okay. Now, so the way you would do this is what you're going to do is you're going to number the seats in each row from 1 to 10. So that's 1, 2, 3, 4. You can kind of see that. And you generate 2 unique numbers. So if you look at the numbers over here, you can see that none of these are repeating in the row. It's okay to repeat across the different strata, because the first strata is row 1, the second strata is row 2. So it's okay if they repeat this way. But they're not supposed to repeat within the strata. So you have 2 and 8, 5 and 7. You would not have 3 and 3. You can have 3 and 4, but not 3 and 3. And then I would repeat, oops, looks like I got a little typo here. I would repeat this process again for each row until I get 10 in my sample, and I average those results, which I did here, and I got 77.9. So which strata should be fairly homogeneous? That means the members in the strata are similar. Which do you think are more homogeneous, rows or columns? So if we go this way, there's my data, there's my average. And the question is rows. The closer you are, the more you spend, right? Because you're doing that because you want to be, like, for example, the most expensive tickets I ever bought were floor seats to a Prince concert worth every penny. And I was very excited to be in the 12th row on the floor seats in that concert in Houston. So the people that are in the front row are spending more money because they want to be in the front. And so they're probably very happy because they're in the front. Whereas people towards the back, not as happy. And in fact, it's funny because I was reading some reviews on another concert just today, and someone said, oh, everyone was standing the whole time on the floor, and since I was further back and short, I had trouble seeing the stage. So this group, because the floor is flat, they might have more trouble seeing the stage. All right. There's my Prince, $300 per ticket. That's how much I spent. Okay, so now we're going to go ahead and look at stratified by columns. Do columns make good strata? Well, this is my sample for strata by column. So if you look, that means I need, let's go to stratified by columns, I need 10 individuals in my sample. How many columns do I have? I have 10 columns, which means I should get 1 person per column, all right? So if we look at my data, I do have 1 person per column, so that's all good. Is it possible to have 3 fans in a single row? I do. In fact, I got 3 fans in the front row and 3 fans in the back row. So yeah, rows don't matter. In this case, because we're stratified by column, columns are what matter, okay? Is it possible to have 3 fans in a column? No, I purposely limited it to 1 person per column. Is it possible to not have fans selected in the front row? Yes, it is possible. Probably not likely, but it's possible. Is it possible to not have fans selected in the last column? No, we need one from every column. So from this data, I went and highlighted it, and I added them all together in this next screen. And I put in my average, which was 81.1. Okay, so how would you tell someone to do this sampling method? Well, each strata is one column of 5 seats. So I'm going to number the seats from 1 to 5. Then I'm going to randomly generate, well, how many people do I need to generate? Just one. One number from 1 to 5 for each column. And I am going to get more than, I'm definitely going to get repeats. So the column 1 was a 1 I generated, right? Column 2, I generated a 4. Column 3, I generated a 3, coincidentally. So I'm picking a 5. I picked the person in the back row. Column 4, I did another 5. So I got another person in the back row. So you could just, these are the random numbers. Let me go ahead. All right. So this is from my particular sample. Other samples will be different. And let me just say, etc. All right. So you keep going and you can figure out, oh, column 5, I got 2. Column 6, I got a 1. And those are the random numbers we generated. And then, of course, once I identify my sample, I record the data for it, which is the satisfaction value. Don't mix it up with their ID number. This is ID number is 1 for this column, but their satisfaction level is 92. The ID here is 4 for this column, but the satisfaction level is 68. So I added all those up, got my 81.1. So the next thing we do is we actually look at the data. So here is the data for the simple random sample, for the stratified by row, and for the stratified by column. All right. And I can tell you that the true value of satisfaction for this was 78.4. So I tried to put these rows in right, but they're not exactly lined up. Let me go ahead. There we go. And 78.4 is probably around here. Ideally, all of these should be centered about that true value of 78.4, which I have marked with a line. This one was a little weird, and it can happen because it's random and weird. You know, randomness sometimes gets you weirdness. I had one student for the first time this year get 12 out of 12 shirts right. The probability of doing that is very low. All right. So weird can happen. All right. It's just not normal. All right. So this one does seem a little biased because it seems to be overestimating, and it could be because remember I have students entering data in here. It could be there were some errors made, but maybe there weren't. Maybe it was just a weird sample. So in statistics, like this sample's gorgeous. This looks like what we expect. Even this simple random sample looks great. This is a little weird that this one's this high. Weird can happen. All right, so which method shows the most bias? Well, there should be no bias because we used random sampling, period. So this one really should be more centered over here, and I don't know why it's not. Looks like we had some bad luck in this particular class. So the third method, stratified by column, is overestimating. So which method shows the least variability? In other words, the tightest pack? It's the stratified by row. All right, stratified by row. Which method would you use for the most precise estimate and why? Stratified by row is the best because it gets some from each group of the people, from the very happy people in the front row to the least happy people in the back row. So again, the whole point of this is sometimes it is good to do a stratified method when you know that there are something like strata, like groups of similar people. Front row people, more money, happy to pay it. Back row people, trying to save a little money, may not be as happy at the concert. All right? And that summarizes our, actually, let me go here. Make sure I cover everything. Oh, which method? And we answered that. And what is bias? It is a tendency to for an average statistic to over or underestimate. All right. Which method shows the most bias? It should be none of the above. To be honest, our stratified by column had some bias, but it shouldn't be that way. Least variability was stratified by row, and we liked stratified by row the most. And that was it. That was the activity.